This section is about pitfalls that arise when developing or using statistics. There are 10 examples, some summary conclusions, and remarks. This screencast will comment on 2 of the examples and on the remarks. You should read the rest. Example 2 is subtle. It says, a company wishes to study the number of consecutive days employees remain on sick leave. To accomplish the study, data is gathered on employees that are on sick leave on a randomly selected set of days. The question for you to reflect on is this an appropriate random sample for the study? You may wish to pause this screencast and think about it. A key observation is that a random sample of days is proposed, but the observations in the population are based on employees, not days. The observations are measured in days, but the measurements themselves are based on employees that have taken sick leave. Another observation is that it's pretty much common sense that the longer you remain somewhere, like a kid at a cookie jar, the more chance there will be that you'll be seen. You should have concluded that the proposed random sample is not appropriate. Under the text box is a simple example. Suppose the population consists of the number of consecutive days that employees that take sick leave during a specific week remain on sick leave. And suppose the population looks like employee 1 is on sick leave for all 5 days of the week. Employee 2 is on sick leave only on Monday. Employee 3 only on Tuesday. Employee 4 on Wednesday. Employee 5 on Thursday. And employee 6 only on Friday. There are 6 employees that have taken sick leave during the week. The total number of days the 6 employees were on sick leave is 5 for employee 1, 1 each for employees 2 through 6. That's a total of 5 more 1 days for a total of 10 sick days. The population mean mu is thus 10 days of sick leave divided by 6 individuals, or 1.67 days. In the population, employees remain on sick leave for an average of 1.67 days. Now let's take a sample of days. To keep it simple, suppose we choose only 1 day for our sample. If we sample on any specific day, for example day 1, we obtain 2 employees on sick leave. The first employee is on sick leave for 5 consecutive days, and the second for 1 day. Thus, the sample mean for day 1 is 6 total days divided by 2 individuals, 3 days of sick leave. The sample mean is 3 consecutive days on. Clearly, this overestimates the population mean. The more general key observation is that for this population, any sample of days will result in a sample mean that overestimates the population mean. Taking a random sample of days is an inappropriate sample methodology. Rather, a random sample of the actual employees that took sick leave during the period should be taken. So the correct procedure here is actually get a list of the employees that have been on sick leave and take a random sample of those employees. The only other example we'll discuss in this screencast is example 5. The punchline of example 5 is that statistical models are based on assumptions that need to be verified before accepting the conclusions derived from the model. Said another way, statistical models involve conditional statements. Here's an example of a conditional statement. The statement, "If Diane brought bread home, then we have bread," is a conditional statement. A conditional statement becomes an absolute statement when the hypothesis or assumptions are checked and verified. For example, when we verify that Diane brought bread home, then we can make the absolute statement, "We have bread." Let's carry those rather simple thoughts over to statistical models. When a statistical model is used, the conclusion might be said like an absolute statement, but its validity is conditioned on model assumptions that need to be checked and verified. It's only when the model assumptions are verified that the conclusion can be considered reliable. For example, it might be said that 68% of observations fall within one standard deviation of the mean. But here's a question for you to consider. On what assumption is that statement, 68% of observations will fall within one standard deviation of the mean, condition? How could you check whether the assumption holds? I'll leave you to think about that one and look, if you wish, under the text box to check your answer. I'll let you read through the other examples. I'll let you read through the summary conclusions. Here's a remark. We'll use the probabilities of 0.05, 5%, and 0.01, 1% often. Let's get an intuitive idea of what these probabilities are. The first rectangular box indicates a darkened area that's 5% of the total area. We'll frequently make an analogy between areas and probabilities. If a blindfolded individual were to throw darts in the direction of this rectangle, then for every 100 darts that actually hit the rectangle, approximately 5 would be in the dark area. That's about 1 in 20. The second box indicates a darkened area that's 1% of the total. If a blindfolded individual threw darts in the direction of this rectangle, about 1 out of every 100 darts that actually hit the rectangle would end up in the darkened area. After completing this page, after completing your reading of this section, it would be a good idea to do homework problem number 1 on the homework 1 doc in this module.